Alternate interior, the interior means that it's inside or in between the what?
The parallel lines.
Not the transversal, the parallel lines, right? The idea of interior is inside the parallel lines. Are those inside, in between the parallel lines?
Yeah.
Yes? Okay, so Matthew's claim was that we have alternate interior angles. A lot of us agree with interior at least. Okay? Claire, what do you think about that statement that they are alternate interior?
They're on the opposite sides of the transversal.
Are they on opposite sides of the transversal?
Yeah.
Now, I will point this out. I didn't draw this, but you can extend, technically this is just a line segment right now, you can extend that though to make it easier to see those angle relationships, right? So that can help you see the angle relationships a little bit better, but yeah, alternate interior angles. Is there anything else that we know as a result of them being alternate interior angles? So they're what?
Both inside the parallel line.
Yeah, I mean they're alternate interior, so yes, they're interior, but those of us who were here last week should know something else about those two angles.
They're congruent.
There we go.
What?
Because they're alternate interior of parallel lines, we know that they're congruent. Austin, Josh.
Not Josh. Josh didn't say nothing this time.
Okay, you were still involved in that conversation because I saw you pointing your ears to try to listen in. So whoever was involved in the conversation, shut it down. Or I will split y'all up again. Don't make me do it. So, alternate interior, so those two angles are congruent, right? We good with that idea?
Yeah.
Yes, Mr. Kenny, we're great. Awesome, moving on. So Ireland, what about 5 and 3? That was the next question. What do we know about those? You know nothing at all? Did you pay attention to the conversation we just had about 4 and 2? What did we say about 4 and 2? Why did we say they were alternate interior? Okay, so you pay attention to this language and make sure you look at your resources because you said some of the right words but not in the correct understanding. Rose, what you got? So they're interior because they're inside the parallel lines. Alternate is in reference to the transversal. You see they're on different sides of the transversal, right? So look over here at 5 and 3. It's the same, right? Again, interior of the parallel lines, alternate sides of the transversal. So, what do we know about angles 5 and 3? They're congruent, okay? So we know that these things are congruent, and an important component of that is, that means that the measure of angle 4 and the measure of angle 2 are what? The same or equal. So remember, when we talk about equal, we're talking about numbers can be equal. Well, the measure is a degree number, right? Or a number that is a degree. And so we know that these measures are in fact equal. Now here's the most important part. Kelsey, what question have you been asking probably for the last, I don't know, 2 weeks it feels like? How many degrees are in a triangle, right?
It's 13.
So this is where it's going to be important that we need to pay attention to this. So let's look up here. First things first, right? So we're going to use this information. Notice we have theorems here. The ideas about alternate interior angles and the congruency there, those are theorems that we have explored. What do I mean by a theorem?
Theories.
Okay, so Pythagorean theorem is another theorem.
Wait.
Okay, it should make us think about the word theory. There's something else that we should know.
It's the formula.
It's a mathematical concept.
Okay, what were you saying? That's just the Pythagorean theorem. Say it again.
Mathematical concept that can be proven true.
A mathematical concept that can be proven true. Did you just know that off the top of your head, Jay?
No.
No, where'd you look?
On my paper.
On the back of that paper that we took notes on, right? On the back of this paper, when we were talking about theorems, and you took notes about theorems, we should have written that down.
Shows my bad handwriting.
That's it, yeah, that's exactly it. I struggle with it every time I have to grade your test, it's okay. I care more about your thoughts and understanding. It's a mathematical concept that has been proven to be true. So we know this to be true. What we're about to prove, and you need to write these notes on that sheet of paper that you drew this out on, because this is going to be fundamental to a lot of geometry. So heads up, write, be ready to write. What we are about to do is look at the Triangle Angle Sum Theorem. Okay? We are about to prove this triangle angle sum theorem, which, Kelsey, what did you think the sum of all the angles in a triangle is?
It's like 100 something.
100 something? Whereas Gabe thought it might be 360, right? Anybody know?
That a circle.
I think it's gonna be a 90-degree because it's a right triangle.
Well, the right triangle would have a 90-degree angle, but we're going to look at something else in a second. Okay,
It's 180.
say it again.
180.
It's 180. Hopefully you remember this from middle school. If you don't, okay, a square or a rectangle or a parallelogram, any quadrilateral is 360. A circle is also 360. A circle actually should be easy to remember. Does anyone know why it's 360 degrees?
Like 360.
So, I want you to think about this, right? That's a circle, correct?
Kind of.
I mean, it's close to a circle. I obviously am not a fantastic artist, but it's close to a circle. So, the idea of a degree was developed forever and a day ago. I don't remember how long ago. But the idea was that there is some amount that is 1 degree. Alright? And that's actually way more than a degree. But there is some amount that when you turn, it's 1 degree. Well,
Don't you got a radius on the same?
there is also a radius. Both of these are radii. But what I'm trying to get to is this. It's not exact, but what shape does the Earth go around the Sun in?
Oh.
Not so.
So the most accurate term is an ellipse. Okay? But it is close to a what? A circle. How many days are in a year?
365.
365.25 or whatever. That's tough to deal with. It's not great in terms of factors. 1 degree, the idea though, was that it is approximately or corresponded to 1 day of the sun going around the Earth going around the sun. That's where 360 degrees legitimately came from in ancient times. They had that idea of 360 days, or roughly 360 days, so 1 day is 1 degree. That's where it came from.
I didn't know how long a year was back then.
They tracked, I know that they tracked, the moon is a big part of it, and so like you could easily see it go from a new moon to a full moon back to a new moon, and that was a component. But that's also why the lunar calendar is not perfect to a year, but they also just paid attention to the seasons.
That's smart.
Yeah. So they were able to approximate those things according to the seasons. But that's where that's coming from. All right. I actually had to do a research paper in college that I discovered that in. It was kind of cool for that reason. But
So
triangles, huh?
180?
So triangles are going to be 180. And so I'm going to go ahead and tell you this. That's what we're trying to prove. So prove the sum of angles in a triangle is 180 degrees. Okay? In geometry, a really important part that we're going to get into a little bit more heavily in the next lesson that we do is this concept of a proof. I am telling you right here and right now that the sum of all degrees in a triangle is 180. But we need to learn how to develop the evidence to prove that kind of conjecture. This is actually what I've been preparing you for very heavily when I ask you to explain your reasoning on assessments and tests and all those things. Because you can't just say something, you gotta have evidence for it. Okay? You've gotta have evidence for why you believe what you believe. Now, before we can prove this, we need one thing to be true. What did I tell you about those two lines? They're parallel. You have to have that statement. Alright? So whenever you do a proof, you always start with a given statement. I'll call this line L and line M for now. So given line L is parallel to line M, what symbol can I put in between L and M to show they're parallel?
Sideways up equal.
It's just two vertical lines that are parallel, right? L is parallel to M. That's the only thing I've given you. I've given you that line L is parallel to line M. Alright? And now we're trying to prove that the sum of angles in a triangle is 180 degrees. Now, I want you to hear me very clearly on this. Proofs can be tricky or hard sometimes because people think that you have to do them in a certain order. You never have to do a proof in a certain order. You need to be able to collect evidence, conclusive evidence, that gets you from where you're starting to where you want to end. And I've already given you a lot of the statements, or a lot of the things to consider. Yes, sir? Okay. So what was the first thing I asked you about on the calculators?
Draw the thing.
Well, I asked you to draw that, yes. But what was the first question? The 1.2. What do we know about angles 2 and 4? So, since angles 2 and angle 4 are alternate interior angles of parallel lines, what did we know about them, right? You'll identify the fact that they are alternate interior. So since that is true, what do we know? There's something else. Angle 2 is congruent to angle 4, right? We knew that statement. And I would even make an extra note. Remember, the measure of angle 2 is what to the measure of angle 4? Equal. So remember, the angles are congruent, their measures are equal. Right? The angles are congruent, the measures are equal. So since angles 2 and 4 are alternate interior angles of parallel lines, angle 2 is congruent to angle 4. What else do we know?
Oh my gosh,
What?
this pen is getting on my nerves.
Made that way harder than it had to be. Okay, so what else do we know?
5 and 3 are also alternate interior angles.
Okay, so 5 and 3 were also alternate interior angles. So what did we know? So they are congruent and their measures are equal. Now I will point this out. I've already written this once. Do you want to write this all out again?
No.
No. Because I'm writing this as sentences, I could just say the same is true for angles 3 and 5. Does that make sense? Like you're writing the story telling me what you know to be true. The same is true for angles 3 and 5. So angles 3 and 5 are what to each other? They're congruent. And so their measures are equal. A little bit shorter that time, since I don't have to write it all the way out. So we were given that those two lines are parallel. We're trying to prove the sum of the angles is 180 degrees. We got some good information going, right? And I want you to notice, at this point, it may not make a ton of sense for how we're proving that the sum of the angles is 180 degrees. We're just establishing key information that we need to know. All right? What else should we know at this point? What was the last question I asked you?
What is 4, 1, 5?
I think this threw some of us off.
4, 1, and 5.
Well, yeah, 4, 1, and 5. What do we know about 4, 1, and 5?
They're unstable.
Okay, if I look at all three of them together,
Also, they also interior side of the parallel lines.
well, if it's more that if I look at all three of them together, they're creating a straight what? Line. What we would call that is a straight angle. More importantly, okay, so let's write that down. So just since I'm running out of room, I'll start over here. So from there, I'm going over to here. Angles 4, 1, and 5 create a straight angle. And that's literally what we call it, a straight angle. Or you could say a line, but they're creating a straight angle. So if I were to add up their degrees, what do we know?
It'll be
180?
It would be 180.
Wait, that's what I'm trying to look.
I'm looking at
4, 1,
4,
and 5?
1, and
Oh,
5.
okay.
Why do I know that's going to add up to 180?
180 is straight.
It's making a line. Okay? Please hear me very clearly. It's not a linear pair because it's not a pair of angles, but it is creating a line, isn't it? A straight angle. So I know that the sum, so angles 4, 1, and 5 create a straight angle. So if I take the measure of angle 4 and I add it to the measure of angle 1 and I add it to the measure of angle 5, what do I get?
180.
180. Hey Kelsey, what are we trying to prove the sum of all angles in a triangle is?
180?
180. Oh, there's the 180, right?
Yes.
But is that for the triangle yet?
No.
Okay. So I want you to notice we have a lot of information. Kelsey, you're looking at like, what in the world, Mr. Kinney? This doesn't make any sense. Okay, but I want you to stop this for a second. I just want us to recap. Do we all agree that angles 2 and 4 are congruent, so their measures are equal? We good with that information? Elisa, you good with that? So then when I look down here at angles 3 and 5, again, alternate interiors, so are they congruent? So their measures are the same, they're equal. And then we all agree that the measure of angle 4, 1, and 5, when we add those all together, they add up to be 180, correct? We good with that? Yes?
Yes.
Hey, really quickly, right here, I said that the measure of angle 2 is equal to the measure of angle 4. So could the measure of angle 2 get substituted in for anything?
Yeah.
What?
What?
I said that the measure of angle 2 is equal to the measure of angle 4.
Cosy.
So can the measure of angle 2 get substituted in for anything?
Yeah.
For 4, right? You mean this 4 right here?
Yeah. Oh my God.
So the measure of angle 2, I'm just substituting it in. Just like if I were to say x equals 5, right? And I have 3x minus 4 is equal to 11. If x is equal to 5, what could that 5 get substituted in for?
X.
X, because they are equal, right? So the measure of angle 2 is equal to the measure of angle 4. 2 can get substituted in for 4. We all caught up and good and comfortable with that idea so far? Rose is like, no, Mr. Kinney, I'm never comfortable in your class because you're talking and I have no clue what you're saying. Are you good with this so far? Okay, just making sure. So notice I substituted that in. And I can't just write this statement. I would have to explain why. So why do I know that I can write this statement here? What did we just use? Because we what? What was the word I kept using? Starts with an S. Substituted.
Yeah.
That one, not supplementary. Sorry, I jumped in and got ahead of you. But we substituted, correct?
Yeah.
Actually, I'll go ahead and say it. Is there anything I could substitute in for the measure of angle 5? 3, right? So let's go ahead and do that as well at the same time.
Why would we do that? Like, what is this?
Hold on 1 second. All right, so notice the measure of angle 2 we substituted for 4. We substituted 3 in for 5 because of substitution. I mean, that's literally what it is. We're substituting. Hey, Kelsey, what are the 3 angles in a triangle? Or in this triangle?
1, 2, 3.
Wait, you mean 1, 2, and 3 right here?
I guess.
It's not a guess. 1, 2, and 3. Yes or no?
Yes.
Okay. Have I put any numbers in here?
No.
I've given you angle names. Sorry, but I haven't given you degrees or anything like that, right? So it doesn't matter what numbers I put into here. I know that they're going to add up to be 180 because these 3 angles are congruent to these 3 angles.
This only applies when they're parallel, right?
Well, but you... I'm trying to think of how to explain this.
Okay, then never mind.
No.
I'm
You're good. It's a good
confused.
question.
Confuse me.
I'm not going to confuse you. I used parallel lines to prove this to be true. It's always going to be 180, okay? Because of this proof. You can't do it without parallel lines. So like I had to give you that statement from the beginning to do this proof. So in order to prove it, yes, we always have to have parallel lines, but that's how we prove that the sum of the angles is 180. Okay? And that is a good question by Kelsey. Why did we need parallel lines?
Because all of them are same, I guess.
How did we know that some of these angles were the same? How did we know,
Because to get alternate interior angles.
right? We had to have parallel lines so that those alternate interior angles were congruent, right? But you can even look at it. Doesn't that angle look to be the same as this one? And this one to be the same as that one? So because I know these 3 add up to be 180, I know that these 3 have to add up to be 180. But notice I didn't just say something that simple. I had to use evidence. I had to use my other theorems and other things that I know to be true to prove it. P.S. Did we all write all this information down for our very first proof that we've ever done in class?
Yep, totally.
Write it down. Good. If you already wrote it down, good. If you did not write it down, pick up your head and write it down now. This is the Triangle Angle Sum Theorem. You gotta know that theorem.
So then what's the formula?
Huh?
Is there a formula for that?
This. This is the Triangle Angle Sum Theorem. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. If you look, that is what we were trying to prove at the very beginning. Right? The idea is the Triangle Angle Sum Theorem that the sum of all angles in a triangle is 180 degrees. Okay? We good with that? Have you wrote all this down, Rose? Okay. I mean, you're showing me the picture, I'm just making sure, and the writing, I know. I just can't see from here that it's all there. How comfortable were we with all of that writing? Not very comfortable?
Oh, no.
Okay.
I'm tired. I'm very tired.
Why? You literally did nothing for a period and a half today.
That was driving out there, it was hot.
It was
That
jumping
in, yelling.
That drained my ears, like,
Everybody was
woke
running
out.
around.
I ain't gonna mind, it was my first block.
His home screen.
And yeah, that's one of the things.
Somebody rolled my couch down. I had to pick it up.
I mean, we can always find excuses. Okay? So, here's the thing though. Today is the only real full period that y'all have with me, so we gotta learn stuff.
Wait, so tomorrow?
Because tomorrow you go to the pep rally.
How long is that?
Well, next week's back to normal weeks.
We just changed.
Because I was confused, that's not all of our classes have changed.
That's not
If your
what's
election.
75 Christmas.
Only some people change classes
Think
next
about what you said.
Yeah.
9 weeks.
Unless you got like 25.
You will be in this class until
750.
December.
Ew.
Then you will be in all four. I know, Kelsey, that's what I'm feeling too.
You lying.
Gotta do it with Kelsey again. Alright. So, here's what I need y'all to hear me on though. I know that some of this was uncomfortable, but all that we're doing with a proof is we are taking one piece of given information and going through the steps to prove this right here. This is probably the hardest proof that we'll do for a while, but this is also a fundamental proof because we need to know that the sum of all angles in a triangle is what? 180. We go with that idea? Huh? Well, what did we try to prove?
The sum of the angles in a triangle is 180.
And what do we see right here? The sum of the three angles is 180. We stepped through all of that to get there.
So we proved it.
We proved it.
Okay.
Notice we used factual statements, we used theorems to get us there. Whew, we are dead. We have got to do something different. All right, so let's get away from that, and I will leave it on the board so you can reference it later. Really quickly, I want to make a note because your tan sheet that's due tomorrow, right here up on the board, I know that the directions say indicate whether each pair of angles is congruent or supplementary by trusting how they look. I need you to write this down if you didn't already do this or did not remember me telling you this or pay attention to the email. You also need to indicate what type of angles they are. Not just whether they're congruent or supplementary. When I talk about angles 5 and 8, what kind of angles could we also call those? Those could be vertical angles. And what do we know about vertical angles?
They're always equal, the measure is the same.
They're measured over the same, or we could just say that they are congruent, okay?
You told me to math.
What can we say about angles 4 and 6?
They're
They're
congruent.
interior, alternate interior.
What?
They're interior.
It's not alternate. It's not alternate.
No, not alternate. They're
Say it again, Josh.
It's not alternate.
They're not alternate. What do we mean by alternate?
They're all
They're on different sides of transversal. I'm pretty sure those are on the same side, right? So what would we call them?
Interior.
They are interior, but what were you saying, Austin? Consecutive or same side, either one. So that's what I need you to do, because if you know that they are consecutive interior, you should know automatically, first off, just look at them, are they congruent?
Yes.
Bro, that is as acute as it gets, and that's obtuse.
Oh.
They're not congruent. There's no way they can be congruent. What are they? Yep. So are they congruent or supplementary? Supplementary. Jalen, can I see this really quickly? Thanks, sir. Yeah, you see this sheet where we did all these different things and we wrote down the theorems on the back? Use your notes on your homework.
I was gonna say I can't spell.
That's fine too. But use your notes, guys. I cannot emphasize this enough. You actually want that sheet out for today's classwork. Okay? But you need to name what the angle relationships are and then use that to explain if they're congruent or supplementary. So, we are just doing practice within our small groups. I'll be doing active collaboration assessments based on that. The whole thing is we need to use the angle relationships created when a pair of parallel lines is cut by a transversal to solve for unknown values. Can you get ready to pass those out? Because I assume some of us have lost it. All right. We need this sheet out. Got it. I don't even know if it was a week ago or a week and a half ago. Okay, Miss Mommy has a few copies. Raise your hand if you need one. Anton, you haven't even looked for it, dude. We're not giving you one until you look for it. You haven't looked for it, bro.
Mr. Kenny, bro.
Why can't I say bro?
Put it on my chair. Hey, cool.
I mean, I use it every day in my
Say something.
my everyday life, so you get over it. This is why we need our notebooks in order. There it is.
Say something.
Okay. Why don't you look through that, middle of that? Alright, is anyone over here needed, or we all got it?
Everything through 19 on the homework, what's on?
Okay. There you go. Nice organization there.
I'm gonna need that.
You need a copy?
I need a copy, I can't find it.
Austin and Gabe in the back need a copy.
And
And Josh.
I might got that.
Alright. So let's get started on doing a couple of these things. Okay? So, I'm just going to do a couple of these with you to help you get started. Yes, ma'am. Yep. No worries. Alright. So let's look at number one. I want you and your group to talk for, I don't know, 60 seconds or so. And I want you to figure out what you think the relationship is between 3x degrees and 2x minus 30 degrees. Okay? So talk about it, figure out what you think the relationship is.
Circle the answer.
You do it like something you do.
I don't know what you're talking about.
No, I'm not saying that. Okay.
Alright, let's talk about it. I said 60 seconds. Some of us were actively talking. I heard Matthew talking a good bit. I heard almost everyone from Group 3 talking a good bit. Group 6 was talking a good bit. Those of us who were talking were figuring it out. Brandon's smiling because he knows that he wasn't talking about it all the time.
We was talking.
Oh, okay. I couldn't tell with y'all, which is why I didn't say anything. I could tell some of the others were not. Okay, Rose, what did your group talk about with 3x degrees and 2x minus 30 degrees?
Oh no, you're good.
Alright, Michaela, what did y'all talk about?
I'm not saying that.
I heard y'all talking. I'm not saying you figured it out, but come on, we should know something. What did we talk about?
What were we supposed to talk about?
Huh? Y'all, I heard y'all talking. What were you talking about?
I was not talking.
I was telling them about the calendar thing. Well, I was looking for the
Oh, she's blind.
not the sheet, but another sheet that
Okay. Well, I need y'all focusing on the things I'm asking you to talk about.
She's blind.
Alright. So Gabe, what did y'all talk about?
We said it was.
Let's talk about what it was,
Yeah.
like, if it was consecutive.
Okay. Are they consecutive?